All right, guys, so this is usually an activity we do in class, but given the way this year is, it just didn't really work out to make sense to do it that way. So we're going to start our unit on trigonometry today, and we are going to investigate what radians are. So you may have discussed this back in geometry. You may have discussed this back in geometry looking at arc length and sector area. We'll do a little investigation into radians. You may have discussed it a little bit last year in Algebra 2, but we're really going to kind of look at what exactly radian is and why they're helpful, why we use them. So what I have here is I just drew a random circle on my paper with my handy compass, and I drew a radius of this circle. And what I did was I took a little pipe cleaner and I cut it the exact length. Here's about the exact length of that radius. So what I have here is this pipe cleaner is exactly the size of one radius of my circle. So if I take this radius and I kind of then look at wrapping it around the edge of my circle. So notice this is different. Those constructions you did back in geometry, if you remember, where you were like inscribing a hexagon, I'm not cutting the corner here. That's what you did in geometry. I'm going to wrap this radius in a circular manner like this. Hopefully that circle's dark enough. Let's see. Can you see that? I hope you can see it. Around my circle. And I'm going to make a little mark. Let's see if I can get really exact. I'm going to make a little mark right there. All right, so again, notice I'm not just making a straight line like shortcut. I'm not just going around my circle that way. I'm wrapping it around the edge. So what I have right there, if I connect my center to that mark I made, this angle is exactly the angle that opens up to exactly one radius length of my circle. Okay, so that angle right here, call it theta. That angle is the number of, well, let me say this again. That angle opens up, it subtends, it cuts into a length on my circle that equals to exactly one radius. So what is this angle that we created? Well, it makes sense to call it 1 radian. Okay, so the radius that is formed, the radius that we use to measure, is cut into by exactly 1 radian of this central angle. So a radian, this is something that kind of gets lost sometimes. You don't have to be jotting all this down, but just, if you want to make some little notes. A radian is an angle measure. So we're all more comfortable, we're used to measuring in degrees, but radians are just angle measures. So that 1 radian is an angle measure that cuts into exactly 1 radius length of my circle. So now I can actually see what this would be in degrees. And when we're looking at it this way, degrees kind of seem like kind of arbitrary, right? So if I measure this, it looks like, yeah, that was pretty good. My measurement is pretty good. If I extend this line a little off, maybe it's about 58 degrees. We'll talk about it and we'll figure out next class exactly what that is. It's actually a little less than 58, so my measurement was a little off. But like, why the heck 58 degrees? What does that really mean to us? Doesn't really mean a whole lot. It's really kind of intuitive to think, okay, one of these radians cuts into exactly 1 radius length of my circle, which is equivalent to about 58 degrees. So now I can keep going around. There's another radius. I can keep going around my circle. So there's another radian. So this entire angle is now 2 radians. I can go around. Let's see how good my picture is. There's 3 radians. All right, so there's another radius worth. So every time I measure a new arc here, it's 57 degrees. So again, why the heck 57? But every time I make a new line here, I have another radius. So 1, 2, 3, 4. And it looks like I'm going to be right on here. There's another radius worth. So there's my 5th radius around the circle. Here's my 6th radius around the circle. So to go from my starting point to where I am now, and if you remember back to last year, we always look at these angles as kind of rotations in our circle. So if I'm thinking about my pen, well, maybe I'll use this. This is better. So I'll use my little pipe cleaner, trying to keep my hands out of the way. If I rotate this angle all the way around, 4 radians, 5 radians, 6 radians, there's a little bit left over. So you guys know why there's more left over. You may not know in your head right now, but you know it. The circumference of a circle is 2 pi. Pi is 3.14, et cetera, et cetera, et cetera. So in my calculator right now, I'm doing 2 pi, and that's exactly 6.283, et cetera, et cetera, et cetera. So we have 1 radius, 2 radii, 3 radii, 4 radii, 5 radii, 6 radii, and this extra little part to go all the way around the circle. I know I have to have 2 pi radiuses, or radii, which is about 6.283. So this last little bit is like 0.283 of a radius. All right, so it's a really big idea. But let me just kind of recap one more time before I get you into your challenge, your brainstorm for today. Every radius length around my circle, is about 57 degrees. 57 degrees, yeah, sure, that's great. We can kind of visualize what 57 degrees is, but we'll talk in a minute. Where do these degrees come from? A radius, if we kind of think about it in terms of, the unit that cuts into it, we have 1 radian for every radius length around the circle. There's 2 radians, 3 radians, 4, 5, 6 radians, and that little extra bit to go all the way around the circle. We have 2 pi radians is equal to 360 degrees. All right, so to make that full revolution, that full circle, I have to go about 2 pi worth of these pipe cleaners. So 283 pipe cleaners give me my full circle. All right, so it's a big idea. Let me show you on this little animation I have. So let's see, can you start again? Let's see if I can copy and paste it. There we go. So there's my radius measure. So 1 radian cuts into 1 radius worth of the circle. And then we can go all the way around. 2 radians, 3 radians, just short of a half circle. And right there is the key moment. If 2 pi is a whole circle, 360 degrees, then 1 pi is half a circle. So it's a really neat way to see it. All right, and that's some useful information that you're gonna need for your brainstorm tonight. Okay, so let's look at what we're these 2 bullet points are in your note packet. So it's a top of did I not number these pages? I guess I did. Oh, top of page, well, it's page 0, I guess. It doesn't have a page number on it. But 6.1 basic trigonometry. A radian is the measure of a central angle subtending or cutting into an arc equal in length to exactly 1 radius of a given circle. And I kind of forgot to mention this, but I could have drawn a circle that was like gigantic. I could have drawn a circle that was super tiny. But no matter what size my circle is, 1 radian is going to cut into exactly 1 radius around my circle. So I could go to like the basketball court and measure the radius of the circle at half court where they do the jump ball. And I can measure 1 radius of that circle. And it will be the same exact 1 radian measure, 57 degrees, that would cut into, the arc of that circle. So it kind of makes a little more sense than to say, well, it's about 57 degrees. So 1 radius is the angle measure that cuts into I'm sorry, 1 radian is the angle measure that cuts into 1 radius of a circle. So why radians? We kind of talked about it. It's a more natural method of dividing a circle into parts. All right, you don't have to write all this word for word. But like, why 57 degrees? Where the heck did that come from? But if I was thinking about cutting my circle into parts, thinking about them in terms of radians is a little more natural. All right, and the 360-degree unit of measurement came from what everything I've heard. Who knows if it's true or not, but this is from what a lot of people believe. Babylonian astronomers who noticed the Earth made 1 full circle about the sun in about 360 days. So they said, okay, we'll make all the way around a circle 360 degrees. So when you look at it that way, it's like, all right, why 360? Could have easily counted wrong, and it could have been 380 or 320 or 340 or whatever. So it's a little more natural way of dividing a circle into its parts. Another really helpful thing is when we're graphing. We're going to spend a whole bunch of time graphing trig functions this year. So last year you probably graphed in terms of degrees. So you had your x-axis, maybe you counted by 45s or 90s. So you had to really scale your y-axis differently so that the graph, you could actually see what was happening. How many times did you plug in like y equals sine x into your calculator and had it in the wrong mode, had it in degree mode, and it just looked like a straight line? All right, so if we count by radians along the x-axis, so 1 radian, 2 radians, 3 radians, 4 radians, it gives us a better way to match that up with the y-axis. All right, but we're going to get to that. Okay, so that's all we're going to do in our note packet for now. All right, we'll get to the rest of these notes in class. We'll do them together. But here's what I want you to do for homework. We kind of talked about this already. So if 360 degrees, a full circle, it takes me exactly 2 pi worth of radii to wrap around that circle. So if 360 degrees is equivalent to 2 pi radians, so the angle measure for a full circle is 2 pi. So we mentioned this one. How many radians would there be in a 180-degree angle? So if I just think about like, okay, 360 is 2 pi. So half of that would be 1 pi. So 1 pi radians would give me a half of a circle. All right, that would give me, get me halfway around wrapping my pipe cleaner. So this is what I want you to put some time into. Think about some strategies you can come up with. How many radians would there be? So how many, what would the angle measure in terms of radians be in a 60-degree angle? How about a 45-degree angle? How about a 210-degree angle? So your homework is to brainstorm a strategy that would work to find the number of radians in any number of degrees. So what if I asked you for a 22-degree angle? How many radians would there be? So there's a bunch of different ways to think about this. You may have something you remember from last year. I don't want you to just go Google it and find this little quick, easy formula, which we will talk about. But I want you to really dig in and think about why and the what behind this. And that's kind of our goal for pre-calc this year. I don't want you to memorize formulas. I don't want you to memorize, just memorize things. I want you to know the why behind it. So take a little screenshot or jot this down. This is what I want you to think about. How can you find a pattern here? All right, and I would love to hear next class. We're going to talk about probably 3 or 4 different ways that you guys come up with. So I hope that makes sense. If you need anything else from me, let me know. I think I'm going to link another video from Khan Academy. He does a really good job explaining this as well. So if my explanation kind of lost you a little bit, I'll link his video as well if you want to watch that as an option to get a little more background into it. All right, so I will talk to you guys soon. Have a great night. See you next time. Bye.